A Food Marketing Institute found that 29% of households spend more than $125 a week on groceries. Assume the population proportion is 0.29, so that is our P value. And a simple random sample of 237, that is our N value, households is selected from the population. What is the probability that the sample proportion of households spending more than $125 a week is less than 0.3? And then a note is given, and it says you should carefully round any z values you calculate to 4 decimal places to match whatever it's called, WAMAP's approach in calculations. So the first thing we have to do is we have to consider the formula that we use to find the z-score for a sample proportion. And there's the formula you've learned to use for this z-score. So the first thing we have to do is determine how different is our p hat from the claimed proportion of p. So our p hat is 0.3, and the claimed proportion of p is 0.29. Now that's only a 1% difference, but we're going to figure out how many standard deviations that is. So we'll do so by dividing that difference by the square root of p times 1 minus p over n. And when we do that, we get a z-score equal to 0.3393. So notice I carried 4 digits after the decimal point, 0.3393. So now we want to calculate the probability that it is less than that. So we're going to have to take that z-score and calculate the area under the normal curve that is less than 0.3393. So our normal CDF command tells us that we have to give it a lower boundary, an upper boundary, a mean, and a standard deviation. So if we picture this, we've got a normal curve. Here's a z-score of 0. Here's a z-score of 1. 0.3393 is somewhere in between those, but closer to 0 than to 1. And we're looking for this area below, since we had a less than probability. So our lower boundary is going to be negative infinity, or a really small negative number. So negative 1e99. Our upper boundary is going to be our z-score, again rounded to 4 digits after the decimal point. Then we have to give our mean, and any time our lower and upper boundary are entered as z-scores, our mean is 0. This is called the standard normal distribution. And our standard deviation is 1, again, when we're using z-scores. And rounded to 4 decimal places, we get a probability that it is less than 0.3393 equal to 0.6328.